An atom is the smallest particle of an element that retains the characteristics of that element. The concept of the atom is relatively new. Although the Greek philosophers in 500 BCE reasoned that everything must consist of minute particles called atomos, the idea of atoms did not become a scientific theory until 1808. So, this time we will discover about the ideas of atomic theory and its development. John Dalton, a scientist and teacher, was aware of these observations. In early 1800, John Dalton developed an atomic theory that proposed that atoms were responsible for the combinations of elements found in compounds. The main ideas of this theory are: 1. Elements are made of tiny particles called atoms. 2. All atoms of a given element are identical. 3. The atoms of a given element are different from those of any other element. 4. Atoms of one element can combine with atoms of other elements to form compounds. A given compound always has the same relative numbers and types of atoms. 5. Atoms are indivisible in chemical processes. That is, atoms are not created or destroyed in chemical reactions. A chemical reaction simply changes the way the atoms are grouped together. Atoms of the similar element are not completely identical to each other and consist of even minute particles. However, an atom is still the smallest particle that retains the properties of an element. Although atoms are the building blocks of everything, atom cannot be seen or even a billion atoms with the naked eye. However, when millions and billions of atoms are grouped together, the characteristics of each atom are added to those of the next until the characteristics associated with the element can be seen. For example, a small piece of the element gold consists of billions and trillions of gold atoms. Thomson was named the Cavendish Professor of Physics at the University of Cambridge on December 22, 1884. Thomson's research on the conduction of electricity in gases earned him the 1906 Nobel Prize in Physics. In the late 1890s, J.J Thomson used a cathode ray tube to show that the atoms of any element can be made to produce tiny negative particles. He knew atoms had a negative charge because he could show that they were repelled by the negative part of an electric field. Thus, he concluded that all types of atoms must have the negative particles, which are called electrons. On the basis of his results, Thomson wondered what an atom must be like. Although atoms contain these tiny negative particles, he also knew that whole atoms are not negatively or positively charged. He concluded that the atom must also contain positive particles that balance exactly the negative charge carried by the electrons, giving the atom a zero overall charge. Given J.J. Thomson's findings, it was only logical to speculate about how the atom may seem. The idea that the atom could resemble plum pudding was put forth by J.J. Thomson and William Thomson. It is conceivable that the pudding contains raisins arranged at random throughout. They concluded that the atom may be conceptualized as a consistent pudding of positive charge with enough dispersed negative electrons to balance that positive charge. Ernest Rutherford, 1st Lord Rutherford of Nelson, FRS, Han FRSE, 4, was a New Zealand physicist who became regarded as the father of nuclear physics. He lived from August 30, 1871 to October 19, 1937. He was awarded the Order of Merit in 1925, received the Nobel Prize for Chemistry in 1908, served as President of the Royal Society, 1925-30, and the British Association for the Advancement of Science, 1923, and was elevated to the peerage as Lord Rutherford of Nelson in 1931. Rutherford came to the conclusion that the nucleus must be tiny and dense, and that it must have a positive charge to counteract the negative charge of the electrons. What material did it have? Rutherford came to the conclusion that protons made up the atom's nucleus by 1919. Although a proton's charge is positive, it is the same size as an electron's. But, how he come to the conclusion? Alpha particles, positively charged particles with a mass around 7,500 times that of an electron, were one of his main research interests. Rutherford discovered that some of the alpha particles were deflected by something in the air while researching the travel of these particles through the atmosphere. This observation perplexed him, so he devised an experiment in which particles were directed towards a thin metal foil. A detector with the material coating that created small flashes whenever an alpha particle struck it surrounded the foil. The experiment's outcomes were considerably different from what Rutherford had predicted. Even though the majority of the alpha particles were reflected backward and deflected at significant angles, some of them nevertheless passed through the foil directly. Rutherford was really surprised by this result. This outcome, according to him, is similar to firing a rifle at a piece of paper and having the bullet bounce back. He anticipated that the alpha particles would only experience very slight path deflections when they passed through the foil. Rutherford deduced from these findings that the plum pudding model of the atom could not be accurate. Only a center of concentrated positive charge that would reject the positively charged alpha particles could account for the enormous alpha particle deflections. The majority of the alpha particles just passed through the foil since the atom is primarily made up of free space. The few reflected alpha particles were those that made a direct strike on the atom's positive center, while the deflected alpha particles were those that had a close encounter with it. Niels Bohr obtained his Ph.D. in physics in 1911 at the age of 25. In 1922, he was also awarded the Physics Nobel Prize. He was of the opinion that the atom may be visualized as a tiny positive nucleus, with electrons revolving around it in a manner similar to how the planets orbit the Sun. The various permitted energy levels appeared as circular circles around a moving electron in his mind. According to Bohr, an electron might change orbits by absorbing or producing a photon of light with the ideal amount of energy. As a result, in the Bohr atom, the hydrogen atom's energy levels represented particular permitted circular orbits. Bohr's model first seemed highly promising. However, additional tests revealed that the Bohr model is fundamentally flawed. It's critical to understand that the current theory of atomic structure is distinct from the Bohr model, even if it served as a foundation for succeeding theories. As planets orbit the Sun in elliptical orbits, electrons do not move in this manner. Sir James Chadwick, also known as James Chadwick, was an English physicist who discovered the neutron and won the 1935 Nobel Prize in Physics. At the University of Manchester, where he studied under Ernest Rutherford, Chadwick graduated with the master's degree in 1913. Chadwick returned to England after the war to pursue his studies at the University of Cambridge under Rutherford. After earning his doctorate in 1921, he was hired as the Cavendish Laboratory's Associate Director of Research in 1923. Subsequently, in 1943, he took charge of the British delegation to the Manhattan Project in Los Alamos, New Mexico, USA. In 1945, Chadwick was knighted. In 1946, he made his way back to London, where he was appointed the United Nations Atomic Energy Commission's British scientific advisor. Along with Rutherford, he researched the nature of the atomic nucleus and discovered that the proton, the hydrogen atom's nucleus, is a component of the nuclei of other atoms. They did this by bombarding various materials with alpha particles. Scientists have hypothesized that there might be more particles in the atomic nucleus after the discovery of the proton. The atomic mass of elements heavier than hydrogen is greater than their atomic number, the number of protons. Suggestions for the extra particles include extra protons, whose charge was protected by electrons in the nucleus, or an unknown neutral particle. Frédéric and Irene Joliot-Curie, two French physicists, bombarded beryllium with alpha particles in 1932 and noticed that an unidentified radiation that was released afterwards expelled protons from the nuclei of several substances. The Joliot-Curies proposed that gamma rays were the source of this radiation. The energy of alpha particles, in Chadwick's opinion, was insufficient to generate such potent gamma rays. He conducted the beryllium bombardment experiments himself and postulated that the radiation was made up of neutrons, which are proton-sized particles without an electrical charge. Since neutrons are electrically uncharged, they can enter the atomic nucleus undeflected, which led to a new theory that the atomic nucleus is made up of protons and neutrons. This finding gave scientists a new method for causing atomic disintegration.